Okay, so we're going to convert between fraction, decimal, and percent. This is a 6th grade standard. This is, so last year when you would have done this, it would have been 6-2 in your 6th grade book. So I know you did it. Whether you remember it or not, you know, that's another story, right? So you do have your guide with you. We are going to start up here with fraction or percent to fraction. Okay? So even before we get started, let's talk about what percent is. So if we break down the word, per means out of, and then cent means 100. Okay, so when we're talking about century, okay, the root word of century is cent, C-E-N-T, which is how many years? 100 years. When we're talking about 1 cent, what are we talking about?
1 cent.
We're talking about a penny, which makes 100 makes a dollar, right? So when we're talking about a centennial, okay, we're talking about 100 years, right? We're celebrating something that has been around for 100 years. So when we're talking about percent, we're talking about something out of 100. Okay? Now there are percents that are greater than 100, there are percents that are less than 100, there are percents that are less than 1. Okay? So things that you might see, you could see this, this. We could even see this, right? Okay. So those are all ways that we represent percent. Now when we say out of 100, this means 1 out of, that's 50 out of, 110 out of, okay? So those are the things we're talking about percent, okay? Out of 100. So we're comparing the value to 100. Now where do you see percents every day in your life? Okay, at a store. How? If something's on clearance, if something's on deal, 30% off, 75%, 25% off, right? So we see that. Tucker, go ahead. Test, very good. There's a certain number that we're looking for out of 100. Now 100% is going to be our best percent, right? Our highest that we can get. Now sometimes if there's bonus, we can go over 100%. But typically, we're looking for out of 100. The closer we are to 100, the better we've done, yes? Okay. Zach, go ahead.
Statistics in like sports and stuff?
Absolutely, statistics in sports. So we're talking about like field goal percentages, pass completion, baseball, your hit to at bat ratio, So we're talking about that as well. Absolutely, in sports we see that the stat lines all the time. Okay, yeah, go ahead.
Nutrition labels.
Nutrition labels, excellent. Yeah, there's 6% of your daily vitamin C comes out of this juice. Or, this contains 25% of your daily sodium intake. Absolutely, very good. Okay. So we do see percents in everyday life. Majority of percent that we find, that we look for, is at stores. Because we're talking about, and that's when we see it, and that's when we use it, because it gives us a certain percentage off. So they give us the retail price, and then they say, oh, this item's 30% off today. Well, you need to figure out in your mind how much it is, so you got to know if you can afford it or not, correct? Okay, so that's what we're going to focus on. We're going to do a lot with percent, with taxes, discount, markup, that kind of stuff. That's what we're really going to focus on. This is probably the most important unit I'll teach you all year. Okay, because this is what you'll actually use in your everyday life. Okay, so this is a very, very important unit. So again, percent out of 100. We're going to look at converting between fractions, decimals, and percents today, just so we're familiar with the representation and how we can use them. Okay, So this right here, okay, this first flap is percent to fraction. Okay, so when we have a percent to a fraction, we rewrite the percent over 100. 42% is 42 out of? Very good, so 42%. So we rewrite the digits over 100. And then we simplify that fraction. What if we have this? Yeah, it still goes over 100, right? We still do this, and then we reduce from there. Okay? Does that look familiar?
Yeah.
The next one, we're going to go down this way, okay? This one here is when we convert from a fraction to a decimal. So we have our fraction, and we need to get all the way down to our decimal. Okay? So we divide the numerator by the denominator. Okay, so divide the numerator by denominator. What does that look like? That looks like this. 8 divided by 1. Okay, or 1 divided by 8. 1's on the inside, 8's on the outside. Okay, so that's not written in your thing, so you need to write that down. Anytime that I write, you need to write. And here we have to use long division to help us calculate. Now, are we going to use long division? What are we going to use?
Calculator.
Our calculator. If you didn't have your calculator, could you do this? Absolutely. Okay. So if you didn't have your calculator and you wanted to convert 1/8 into a decimal, we would do 8 divided by 1. 8 doesn't go into 1, so what do I need?
0.
Okay, not just a 0. I need decimal and zeros to be my placeholders. 8 doesn't go into 1, so I put a 0 in there for my placeholder. I bring my decimal point up. 8 goes into 10 once. 1 times 8 is 8, and I subtract. 10 minus 8 is 2. 8 can't go into 2,
0.
so I need to bring down my 0. 8 goes into 20 twice. 8 times 8, sorry.
So fast.
2 times 8 is 16. And again, I subtract those two. 20 minus 16 is 4. 8 can't go into 4, so I bring down my last 0. 8 goes into 40. 5 times. 8 times 5 is 40. I subtract and I get a 0. Okay? Now, when we're doing this, this might go on forever and ever and ever, right? So that's going to be our irrational number. Non-terminating, non-repeating decimal. Okay, so that could happen. So we need to go out as far as we need to see what's going on if we don't have our calculator. Okay? If, let's look at something else here. 2/3. Okay? So if I'm converting, I've got numerator over denominator. So that is D comes before N in my alphabet, right? So denominator goes on the outside, numerator goes on the inside. That's an excellent way to remember. So 3 into 2. Does 3 go into 2?
No.
So I pull my decimal point right up. 3 goes into 20 6 times, so I have 18. 20 minus 18 is 2. Pull down my 0. 3 goes into 20 6 times. What's happening?
It's a repeating decimal.
It's a repeating decimal. It doesn't matter how many times I do this, I'm still going to get 6, I'm still going to get 18. So this is going to keep on going forever and ever and ever. So what I would do then is I would say 2/3 is equal to 0 and 6/10 repeated. Yes, Sam?
Can't you like, at one of the, at like the end decimal, you can put like a 7 in there?
The calculator does that, but 0.6 repeating and 0.66666666667 is not the same number. Okay, it's not close. It's a good estimation, but 0.6 repeating and 0.666666667 not the same number. You're going to get different values if you use both of them to multiply. This is the best representation of it. Okay, you could say. You could say that. 2/3 is approximately 67/100, because that tells someone it's not exact, but it's pretty close. Okay? The problem is, like, this symbol is not anywhere to be used unless you're writing it out. So, like on a state test, that symbol is not available. On an SAT and an ACT, that symbol is not available. Like on a on a handwritten test, you could definitely use something like that. And we use this a lot in geometry, especially when we're dealing with circles, because we use pi, and pi is a non-terminating, non-repeating decimal. It's an irrational number, so we can't get an exact value. So we do use this a lot in geometry, especially when we're dealing with circles.
So why does like that calculator, even in PowerSchool, instead of it being 6 repeating, they want it to 7?
Because they only have so much capacity. Like calculators only have 10 digits to use. So they don't, so they round that last one up. PowerSchool's the same one. They only have so much capacity for calculation. Good question. If you think that something is an irrational number, okay, so we can't convert it to a fraction because we don't convert fractions to irrational numbers, right? They're just non-repeating, non-terminating decimals. In your calculators, if you have your calculator out, I want you to do, let me get Desmos up here. So on your calculators, if you have a handheld calculator, there's if you go to the second row here, and you go all the way down to the x squared button, okay, that is, now yours might be different, so just wait a minute. Right above it is the square root button, which is this right here. So if you have a handheld, I want you to go second x squared. Okay, and yours will look like this on the handheld calculator, right? I want you to put a 2 in. Shane, focus, honey. Okay, if you're using Desmos, just put in a 2. Not my day. Okay, do you see that value?
Too far.
Oh, this is right here. 2, and then this.
You're the black watermelon.
Okay? What do you see here? It's a large decimal, right? Is it repeating in any way? It's not repeating in any way. A lot of square roots are going to be irrational numbers. We can't write these as fractions. Okay, so you won't have to worry about converting a fraction to a irrational number. They might look like it, like 1/7. So if I go 1/7, that looks like an irrational number, right? 142857, 142857, 142857. So it actually repeats 6 times. There's 6 digits that repeat over and over and over again. So it may look like an irrational number, but 17, 27, 37, 47, those are not. Yes, Jared?
Mine only goes up to 1.41421.
That's the photomath calculator? Okay. All right, let's forge ahead. Just some things to see and think about, right? Okay. The next one here is where we're converting a decimal to a percent. Okay, so that's our last value. So, move the decimal point 2 places to the right and then add a percent symbol. So, we start with our decimal and we move it 1, 2 to the right, so we get 75, and then we add our percent symbol. Okay. So you should have 2 loops here, 75, and then we add the percent symbol. So move the decimal 2 places to the right and then add the percent symbol. Basically what we're doing to do a decimal to a percent is we're multiplying by
100.
Okay, so to convert from a decimal to a percent, we multiply by 100. So again, to convert a decimal to a percent, we're multiplying by 100. So that goes for any decimal. That goes for decimals that are over 1, over, anything that's way under, we can use that. So again, we're multiplying by 100. So if it doesn't actually stop, it just gives me my, I'm on low battery. Thank you though. Okay, so here, we've got 125 thousandths. If I move my decimal 1, 2, what's my percentage?
12.5.
Okay, and that is okay to still have a decimal in the percentage. As you get into 8th grade, you might see something like this. Okay, so then we're going 1, 2, so we've got 0.000, sorry,
10,000
okay, so we could see that as well. What is 8 as a percent?
800.
So our decimal's right here, right?
It would be
1, 2. We don't have anything there. What do we fill in our holes?
zeros.
So 8 is actually equal to 800%. Okay, so that's something you might see as well. All right, up here. So now we're going to go the other way. Percent to a decimal. So we remove the percent symbol. And we move the decimal point 1, 2 to the left. So we remove the decimal point and we move our decimal 1, 2 to the left. What am I actually doing?
Making it small.
We're making it smaller.
Dividing by.
Down here, when we converted from a decimal to a percent, we multiplied by 100.
Dividing by 100.
So here, percent to a decimal, we're actually dividing by 100. So this one here, we're actually dividing by 100. Okay, the next one, we're converting from a fraction to a decimal. So there are several more steps that we have to go through. Our fraction has to go to a decimal and then go to the percent. Okay, so we need to take our fraction, convert to a decimal, and then to a percent. So we have to convert the fraction to a decimal. So we'll need to use this here. That's why they're next to each other, because you need to use this to make this possible. So we divide our numerator and our denominator. Then we move our decimal point 2 spaces to the right, and then we add our percent symbol. Okay? So fraction gets converted to a decimal, and then our decimal gets converted to a percent. Okay, again, can we use our calculator if we have it? Yes. If we don't have our calculator, we need to use long division. So our last one, we're converting from a decimal all the way down to a fraction. So we put our digits over 100, and then we reduce our fraction. Okay, so remove the decimal point, rewrite the decimal over 100, simplify. Now that's only if you have, put this down. That's only if you have 2 decimal places, right? What if I've got 3?
Then you have to multiply by 1,000.
Okay, then you put it over 1,000. If you have 4, you put it over.
10,000.
If you have 1, you'd only put it over.
10.
Okay, so that's something else we have to think about. This is just very vague in general, right? This is not the end all be all. We got to think about how many decimal places we actually have. So, if we had this, we have 3 decimal places, so 125 actually goes over 1,000 because it's tenths, hundredths, thousandths. If we have this, we only have a tenths, so we would put it over 10. We have this, okay, it goes tenths, hundredths, so we put it over 100. Okay, so it depends on how many decimal places we have, the number that we actually put it over. Is that coming back to you now? That you did this last year? I know well, you were supposed to do it, and I'm pretty sure you did it. Okay. What? You weren't?
I think we started it and then we went
And then you went online? That makes sense because it's topic 6. So it does kind of make sense.
yeah, wasn't today supposed to be the day that we went online?
Today was actually the last day we were in person last year, the 12th. Because then on the 13th, you guys did your career shadow day. If you did that, then we did that on that Friday. And then that Monday is when everyone went online.
Yeah, 'cause on Friday we couldn't do, the shadow.
Oh, you didn't do some of you didn't do it?
I
didn't do it.
I did my
So.
dad
I didn't. Most boring day of school ever.
Oh no, I did.
Okay. Alright, no homework. Okay. So we'll start next week with actually finding percents of numbers.